Welcome everyone to another edition of Trouble in Your Tank, Take 5. My name is Michael Carano and I'm with RBP Chemical Technology in Milwaukee, Wisconsin. We're going to be talking about some interesting topics in the printed circuit board area. And today's topic is going to be on organic solderability preservative technology. With the question to you, are all OSPs the same? And how does an OSP actually protect the copper base? As you can see in this slide, the OSP is applied as an organic coating, and the nitrogen groups on the 5-membered pyridine ring react with and put a thin organic coating on the copper surface, which then allows the copper to remain in a oxidation-free state, because we all know that oxidation on copper can destroy solderability. Now, the OSP film itself, as I said, is an organic film as opposed to metallic coatings such as immersion silver, nickel and gold, immersion tins. But OSP is an organic. And most people have thought over the years that OSP is a weak coating in terms of protecting the copper surface from oxidation. But over the years, thanks to significant research and improvement in developing new reaction products, today's OSPs are a significant improvement over last 10 years of OSPs. So you can see here in this schematic, we show how the new coatings have a higher ability to cross-link and then improve and minimize effects from humidity and from oxidation with a higher cross-linking density that you can see on the right side of that slide. Now, the question about thin versus thick. What is a thin OSP coating? Well, let's put it this way. Thin versus thick, when we hear that discussion, should not be confused with how good the product is. The ability, again, the key is the ability of the OSP film to coat the copper uniformly and have a minimum thickness that is designed to prevent oxidation and humidity from interacting with the copper surface. So you will see in various specifications, you'll see 2 thickness ranges for OSP. One I refer to as thin, which is typically between 0.15 and 0.3 microns. And the other is thick, between 0.3 and 0.6 microns. Again, it is up to you as a fabricator and as an OEM who may be specifying OSP for your boards to check with the supplier and the fabricator using these processes of whether or not these are truly super, solid coatings that minimize, again, the effect of oxidation and humidity. So again, the technology says thin and thick both work as long as, again, the key is preventing oxidation penetration to the copper surface. Now, as you know, we've said before, OSP is an organic coating. And it's only a temporary coating. In other words, during the process of assembly or soldering, when the fabricator either goes through wave solder or printing solder paste for reflow, the fluxes both in the solder paste and in the flux during once it becomes activated will remove and dissolve the OSP film. And as the OSP film dissolves, it allows the solder to spread and make complete contact with the copper surface. This is different than, let's say, immersion gold over nickel, where the gold actually dissolves in the solder. In this case, OSP just completely dissolves and basically is, if you will, sublimed, if you will, into the atmosphere, and no longer stays with the solder joint that has been formed. So there are some differences here. Now, regardless of what OSP you pick, whether it's the thin versus thick, there's several things you should ask. Number one, you've got to control the thickness. So there are several areas in process control that are critical. One is to maintain the pH in the required range. pH is important because that allows the coating to form uniformly and in the proper thickness. With most OSPs, if the pH is too low, the coating will be very thin. If it's too high, it can be excessively thick. And that's not good either. So again, keep pH in the required range depending on the process you're using. Certainly, the time in the solution affects the growth of the OSP film. The good news is most OSPs easily form to the proper thickness within 45 seconds and 60 seconds. So it's a pretty simple process. Of course, like all cleaning and coating processes, temperature is important, as well as the concentration of the azole coating itself, which again, OSPs are based on some type of imidazole coating, which I showed you at the beginning of this recording. So again, keeping the pH in control also has to do with in maintaining the process, the proper ventilation. And one thing you can do to control the pH is that all OSPs need some type of an acidic ingredient, whether it's any type of acid that keeps the, like acetic acid or formic acid, which keeps the organic material in solution. If that acidic ingredient is not being controlled properly or it's evaporating, that will also cause changes in the pH, which will then affect our coating. We always believe that proper surface preparation is critical to any process. And OSP is no different. And you'll hear me talk about surface prep prior to electroplating, surface prep prior to photoresist in subsequent presentations here on Take 5. But surface prep is critical. You must have a clean copper surface, freely of oxides and completely properly microetched so that the OSP coating can form uniformly. You can do all those things I just said earlier correctly, proper pH control, proper time and temperature, but if your surface is not clean, you will have non-uniform coating. And I'm going to call your attention to the picture on the right. You see those dark spots there? There's some nice clear areas which look light. That's where the OSP coated. Those dark areas are areas where the surface was not properly cleaned. There was some oxidation left there. And guess what? The OSP did not form there. And that's going to cause an issue with subsequent assembly, in other words, solderability. So clean surface prior to applying the OSP is very critical. Here's another example of inadequate surface preparation. You can see how the pads, after being exposed to air, and you can see where the arrow is pointing, you can see the darkness around the pad. That's oxidation. That's because the surface wasn't prepared and cleaned properly. That means having a clean copper surface free of oxides, any soils, and then going into a microetch like peroxide sulfuric or sodium or ammonium persulfate so that we can actually roughen the surface that will allow us to give good uniform coating. And you can see on the right here, I point the arrow showing a non-uniform surface area. That area is going to give us, or that arrow is pointing, is going to give us an issue with getting a good uniform thickness coating in that area. On the left is a properly microetched surface. Notice the high surface area, good clean roughness, no smooth areas. That's an excellent surface for which the OSP can coat uniformly and effectively. Here's a good example again. Oftentimes we have non-uniform thicknesses or dirty surfaces, minimize the OSP coats and forms. Again, the arrow is pointing to a discolored area here. This is oxidation. The other pads, the fingers, seem to be looking really good. Again, this is a surface preparation situation. Something was left on the surface, not cleaned properly, and it was affecting how well the OSP film coated. So again, process control. I can't stress enough the importance of microetching. Not only must you have a clean surface, but you must have a properly microetched surface. All three of these, hydrogen peroxide, sulfuric acid, potassium persulfate, sodium persulfate, you must have a sufficient micro etch that allows you to get at least 20 to 30 microinches of copper removal. With that said, these will give you, again, a much better opportunity to have a uniform coating. But I do want to caution you, if you have an excessively etched surface, it does negatively impact the uniformity of how the OSP coats. So I want to be clear about that. Typically, I like a smoother, more uniform surface rather than a deeply etched surface. And we'll talk more about that in subsequent offerings here of Take 5. So some actionable items to you, which is what I like to have you understand with each one of these short little presentations. Know the OSP chemistry you're using. Is it, for example, compatible with lead-free assembly, or is it only one of those OSPs that are amenable only to lower temperature assembly, which again affects the ability to assemble in multiple reflows if necessary. The process controls for OSP are simple, but you need to know the OSP concentrations, got to keep it in control, along with temperature, pH, and dwell times. All of those will affect the uniformity of the coating. And again, I want to stress, don't get worried about thin versus thick. It's the ability of the coating to resist oxygen penetration. And that's up to you to understand that and test that before you implement that in your system. And again, surface preparation, there is no excuse. You've got to have a clean surface. OSP is not going to cover, this coating itself is not going to cover up any mistakes or lack of cleaning or poor cleaning or surface preparation. You've got to make sure those processes up front are done and done completely.